Hello everyone, I am Umamahesh Reddy Ipala, a master student at the University of Florida. This presentation is for the wireless communication course, and the topic of this presentation is signal to interference plus noise ratio comparison of the RNC and HARQ protocols. Going on to the introduction, the usage of cellular phones has always been on the rise since its inception 42 years ago on the 3rd of April 1973. Though initially cell phones were developed for making and receiving calls, gradually we were able to perform other operations such as sending and receiving short messages, sending video messages, and then also able to access the internet. All this is because of the advent of technology, wherein a lot of research has been going on to develop cellular standards to transmit multimedia messages. A survey has been conducted by the University of Edinburgh at Scotland with regards to the traffic generated by mobiles and laptops. It was inferred from the survey that mobile traffic usage and mobile data traffic would grow exponentially in the years to come. A major factor for this growth in traffic is due to the multimedia messaging services, the MMS. As a direct consequence of this, many protocols have been developed so that the multimedia messages can be transmitted from the source to the destination with a very high efficiency. This shows the summary of the survey that was conducted. The graphs on the left indicate how the traffic is being used. It can be seen from the pie chart that 48% of the traffic is generated due to the smartphones alone. Now, going into details of this 42% is what is explained by the graphs on the right. It is seen that over the next 5 years, there would be an 18 times increase, 18 times growth when it comes to the video related services for mobile phones. This is evident from the fact that 70% of the traffic is due to the video related services, or in short, the MMS. Now, the main objective of this presentation, it's a simple 2-point objective. The first one being the implementation of the MAC RNC protocol. RNC stands for Random Network Coding. The second objective is the implementation of the MAC HARQ. HARQ is the acronym for Hybrid Automatic Repeat Request. And then comparing both the above mentioned protocols on the basis of SINR, which is being used as the base or as a tool to bring about the performance analysis. Now, just a brief overview about what LTE is before going into the intricate details. LTE stands for Long-Term Evolution, which is a high-speed wireless communication standard aimed at mobile phones and data terminals such as personal computers and laptops. The standard was developed by the third generation partnership project, 3GPP. The objective of LTE is very simple. It's to increase the capacity and the speed of wireless data networks. When it comes to downlink, LTE uses OFDMA, Orthogonal Frequency Division Multiple Access, as it is highly suited to achieve a very high data rate for standards related to LTE, but it is not so when it comes to the uplink. This is because LTE uses a technique called single carrier FDMA, suppressed as SC FDMA. It is somewhat similar to OFDMA, but the difference arises in that there's a 2 to 6 dB peak to average ratio difference, and suppressed carrier FDMA has an advantage over OFDMA. Therefore, LTE uses the SC-FDMA technique for uplink services. Now, one of the minor drawbacks of LTE is that it has different frequency bands of operation in different countries. Taking an example, in Asia, the LTE bands extend between 1800 to 2600 megahertz, whereas further south in Australia and New Zealand, the operating band is around 1800 megahertz. So as a result of this frequency variation in the frequency bands, phones from one country may face certain issues and problems when taken to another country. Therefore, it is highly advisable that users use multi-band capable phones when it comes to international roaming. Now, this is the general architecture of the MAC HARQ, or in general, this is the LTE architecture. It consists of 4 layers: PDCP, standing for Packet Data Conversion Protocol; RLC, Radio Link Control; MAC, the Media or Medium Access Control Layer; and finally the physical layer. The PDCP is ideally aimed at header compression and ciphering, whereas RLC performs segmentation and retransmission as ARQ, error correction technique, is implemented in this stage. MAC layer is the place where HARQ is implemented along with operations such as resource scheduling, placing data into transport blocks, and a few other related operations. Finally, the forward error correction technique is what is implemented in the physical layer, along with modulation techniques and mapping the data onto the physical channels. Now going into the operation of MAC HARQ, but before that, this slide just gives a brief overview of what I previously explained. HARQ operates in the MAC layer and is associated with retransmission and scheduling. HARQ in the MAC sublayer performs retransmission of those blocks that are corrupted. Corrupted implying loss of packets or merging of packets leading to incorrect data, and a majority of all other transmission errors. Therefore, the fundamental design of LTE is to not only transmit and propagate, is to not transmit any bit errors to the higher layers. Therefore, what it does is it retransmits the entire data unit containing the bit errors. Therefore, the error is not propagated to the next level of layers. Now, the HARQ working scheme. This is how the packet is transmitted from the highest layer, which is the PDCP layer, to the lowest layer, the physical layer. Now, before going into the details, two things have to be made very clear. One is the service data unit, SDU, and the other is the protocol data unit, PDU. SDU is used to refer to a packet that enters a particular layer, whereas PDU is a term given to the packet that leaves a particular layer. Now that those two terms are clear, going into the details, the IP packets enter the base station, which is generally referred to as the E node B, through PDCP. What PDCP does is it removes the IP header from the PDU, adds its own set of tokens that are 1 to 4 bit long. The main purpose of adding these tokens is for identification. This entire process is called header compression. After header compression is performed, PDCP passes on the packets to the RLC layer. The encapsulated packets in the form of the PDU is delivered to the RLC layer like I previously mentioned. RLC layer is the place where segmentation takes place. It is one of the most important features of HARQ. Segmentation happens when, say suppose the particular SDU is large or the radio data rate is very slow, then the SDU is split into many large packets. On the other hand, if the SDU is too small or if the data rate is too high, then many packets are fused together to form a single PDU. This is called segmentation. What RLC does is it adds its own header bits to the RLC mode according to the RLC mode of operation, and it passes on these packets to the MAC layer. Now the MAC layer in turn adds its own set of header bits, pads it so that it fits the transport block size of the MAC SDU, and then passes it on to the physical layer. The physical layer in turn sends it to the destination that receives these messages. Now for the main objective of this presentation, SINR calculation. SINR is actually a combination of various factors. The factors are visible on the screen. They are the transmission power, represented by PTX, GTX and GRX, which are the gain of the transmitting antenna and gain of the receiving antenna respectively. NRX stands for the noise at the receiving end of the antenna, and that has to be subtracted from the SINR. I stands for the intercellular interference, whereas S is the shadowing loss. PL stands for the path loss. Finally, PNL is the wall penetration loss. Now say suppose the final user or the user equipment is confined within 4 walls, then when a signal is transmitted or sent out to the destination, the final destination, which is UE, then as it passes through the wall, there is a certain amount of loss that is incurred. This loss is called the wall penetration loss, and it is also one of the factors that determine or degrade SINR. Network coding. Now, a brief idea of network coding before going into RNC, which is random network coding. In network coding, nodes perform two functions. It first stores the received data and forwards them. Secondly, it also mixes the output packets. Now, the main advantage of this is an increased throughput, and the amount of energy required to multicast the package to the destination is reduced. At the same time, the slack or the time is also reduced. Now, this diagram, which is called the butterfly diagram, brings about the difference between traditional routing and network coding. The diagram on the left, the butterfly diagram on the left, what happens is there are two packets, B1 and B2, from the source, which is passed on to the forwarding node T and U. From T and U, both these packets are passed on to W, which is a forwarding node as well. From W, the packets are again passed on to X. Now, X spends a certain amount of time to determine which packet goes to which destination. Thereby, some amount of energy and time is wasted. So, the throughput is 1 bit per time unit. Now, going on to the network coding. On a similar basis, the source forwards the packets B1 and B2 to T and U. Now, W does not perform as a forwarding node, but it performs as a mixing node, wherein both the packets B1 and B2 are mixed together and they are passed on to X, which functions as a forwarding node. X does not waste any amount of time in determining which packet has to be sent to which destination. In turn, both the fused or the combined packets are sent to node Y and node Z. Now it is the function of Y and Z to determine which packet they need and which packet is not needed by them. So, from the slide it can also be seen that the throughput increases to 2 bits per time unit, which is double as what is offered by the traditional routing. Now, random network coding. To define a real network is the one in which the packets suffer from random delays and losses. Now, when it comes to the proposed RNC scheme for LTE or LTE Advanced, what it does is the size of the messages or the blocks in which the messages are sent are very small. They're short to medium. They have a fixed size. As a result of this, there is an enhancement in the throughput and energy is also saved. Now, this is how the RNC scheme performs. The packets are sent from the PDCP layer. This is how the packets are sent from the PDCP layer to the final physical layer. Initially, it's very much similar to the HARQ scheme of things, as in the packets enter the base station E node B at the PDCP layer. The PDCP layer passes it on to the RLC layer. Now, it is in the RLC layer that one of the major difference arises. There is no segmentation performed. That is, when a packet arises, it is passed on to the MAC layer as such. No change is performed on it. And in the MAC layer, there is an additional layer called the MAC sublayer, wherein these packets are encoded. They're randomly encoded so that they have an identification number and the corruption is also lesser. So when these encoded packets are placed into blocks that have a fixed size, and the number of blocks to be placed in a packet increases arithmetically. That is, one block has 2 packets, the next block has 3 packets, and so on. Now these MAC PDUs are passed on to the physical layer. The physical layer has a transport block of a fixed size. In the transport block, there is a fixed amount of packets that can be taken in. Now say suppose one transport block takes in 2 packets from the MAC layer and has the option of getting another packet, then it takes the other packet from the MAC layer and fuses it together. Now the question might come that what happens when it comes to identification, and what if the packets are mixed, that is, what if the packets are corrupted? Now the encoding that is performed in the MAC sublayer comes to rescue because it acts as the identification number. So once they're placed in the transport block, they are passed on to the destination, and once each packet or each transport block is received at the destination, it sends an acknowledgement signal. Whereas in the HARQ scheme, there is an acknowledgement signal received for each packet. Therefore, the acknowledgements are reduced in the RNC coding scheme. This slide gives a brief explanation of what I have done so in the previous few seconds. Now, why random network coding? 3 reasons. Simpler architecture. RNC reduces the overhead, as in there is not much amount of time that is spent at each layer, as in it is just passed on from one layer to the other with the minimum amount of overhead. And it is well equipped to handle packet errors that arise due to changes in the channel, and they do so in a very robust manner. Now, the RNC advantages when it comes to HARQ, like I previously mentioned, there is a minimum amount of overhead, and redundancy is included only at the EUTRAN links, nowhere else in the network. Secondly, the number of feedback messages for RNC is very less when pitted up against the HARQ protocol. Thirdly, the RNC network manipulates the packets directly. It does not segment them. It does not break them into into more packets, or it does not fuse them to to reduce the number of packets. It operates directly. So finally, during RNC encapsulation, the RLC layer exploits something called content awareness, which is enabled by the addition cross layer interaction which is a feature for video coding process. Now these are the results. This is the SINR as opposed to the distance for HARQ protocol. This is the similar SINR graph obtained for the RNC protocol. And these are when two graphs are pitted against each other. And this is for the decoded packets versus the retransmission packets. Now to go into the MATLAB simulations, firstly, the SINR comparison. It consists of four functions: path loss, compute SINR, compute path loss, and compute shadow loss. Now while running this code, we get the following output. It can be seen from the graph that SINR of RNC, which is represented in red, is considerably higher when pitted up against HARQ, which is represented in blue. And this is a graph of SINR versus distance, that is the distance from the source to the destination. Now what exactly can be inferred from this graph is the SINR value is higher for RNC, thereby indicating that it is better and it is less affected by noise. The number of retransmissions are reduced, the amount of time is reduced, and the corruption, mainly the corruption of packets, is very minimal when compared to HARQ. Now to go for the second graph, which is the graph of decoded packets versus the retransmission packets, it has one function called NCL, wherein this function is used for matrix division and matrix multiplication to find which packet gets decoded according to which transmission bit. Okay, so running the code, this is the following graph that has been obtained. And this is made for the worst case scenario of decoded packets for versus retransmission packets. What this graph implies is for every decoded packets, there has to be a certain amount of retransmissions that has to occur. This is because as one packet is sent to the destination, you get an acknowledgement signal, and based on that, if the retransmission has to be made or not would be decided. Now this is a graph that indicates that. Going back to the presentation, this is the graph of the retransmissions, RNC retransmission that I just mentioned. These are the references. Thank you. That is the end of the presentation. Thank you and have a great day.